Hey scholars, I hope y'all are doing great today. For this lesson, we are going to be talking about inscribed shapes. So we're going to be building off of what we've talked about with inscribed angles. So make sure you are paying close attention and taking good notes. Let's get going. Alright, so let's check out this circle. What I notice when I look at this circle is, at first glance, it looks like it has a bunch of different triangles kind of intersecting each other. That's what it looks like, at least to me. But let's try to look at it a little more closely. Let's look at this red angle. See this red angle here, ACB, this blue angle, ADB, and this green angle, AEB. Those are actually three different inscribed angles that are just intersecting each other. And it looks like they form triangles. Here's something that we can learn about these. If these inscribed angles of this circle intersect the same arc or are subtended by the same chord or arc, then those angles are congruent. Let me make that a little simpler. Here's the deal. All of these angles, ACB, ADB, AEB, they all intersect this arc AB. And check this out. They all begin with A and end with B. ACB, ADB, so AB, and then AEB, AB. They intersect this arc AB. So, if they all intersect that same arc, all these angles must be congruent. So, check this out. Let's say that this arc is, 100 degrees. Well, these are all inscribed angles of that arc. So this angle E right here, AEB, that angle E is going to be 50 degrees. Remember, it's half of that arc. So same would be the case for these angles C and D. That would be 50 degrees. C is going to be 50 degrees. Because they all intercept the same angle. So all of those angles are going to be congruent. So check this out. We've got another circle here, and we see what looks like a right triangle in that circle. We have a right triangle in that circle. Now, the hypotenuse of that right triangle, it looks like the diameter of that circle. See how it's passing through the center? It is the diameter of that circle. So what we can see here is that an inscribed angle subtends a semicircle if and only if the angle is a right angle. So this is telling us that if we have a right angle here, then the arc that it subtends, let me try to trace over that, make it a little thicker there. This arc is a semicircle, okay? Half of the circle. There's the arc that it subtends. So here we got our 90-degree angle, and then this arc is going to be 180 degrees. Okay? So here we go. Let's work some problems. So number one tells us to find the value of x. So let's see, we're actually going to be just applying what we already learned. What we have here is we have a diameter. See, RT passes through this point S. So this must be a diameter. Well then, if that's the case, we have a right triangle here because this diameter cuts the circle in half. So this is a semicircle. So if this is a semicircle, then this must be a right angle. This triangle is going to be a right triangle. Well, we're being asked to find the value of x, right? And we know that this angle is 4x plus 6 degrees. And it's referring to a 90-degree angle. So that must equal a 90-degree angle. So what we can do here is we can just go ahead and get rid of the degree signs here. We can actually, it's like we're dividing it out. But what we'll end up having is 4x plus 6 equals 90. So then solve this out, subtract 6 on both sides. We get 4x equals 84. Divide both sides by 4. We get x equals 21. So the value of x is 21. 4 times 21 is 84. 84 plus 6 is 90 degrees. Okay, so That angle is 90 degrees, x is 21. All right, now let's solve for number 2. Well, we're being asked to find the measure of angle ADC, so let's trace that right here. So this is the angle that we're trying to find. So the 7y minus 1. So the arc that it subtends, I'm going to put this in a different color here. The arc that it subtends is AC. Okay? Well, check this out. We see that this other angle, this other inscribed angle, ABC, also subtends arc AC. So what we know is that angle ABC, let me write it here. Angle ABC is congruent to angle ADC because they subtend the same arc. So the measure of angle ABC, it's going to be 10y minus 28 degrees, and that's going to equal 7y minus 1 degrees. So again, we can just go ahead and eliminate our degree symbols, and we just get 10y minus 28 equals 7y minus 1. I'm going to add 28 on both sides, and we're going to get 10y equals 7y plus 27. Subtract 7y on both sides. That's going to give us, I'm going to write this over here, that's going to give us 3y equals 27. Divide both sides by 3, we will get y equals 9. Okay? So we found that y equals 9, but the question is asking us to find the measure of angle ADC. So ADC, we're going to substitute 9 in here. So 7 times 9, that's going to give us 63. 63 minus 1, well, that's going to give us 62 degrees. Okay? And then you can check this with the other angle. We should get 62 degrees for the other angle, right? So 10 times 9 is 90. 90 minus 28 is also 62 degrees. So the measure of angle ADC is 62 degrees. All right. Let's move on. This is the last thing we'll talk about for this lesson, the inscribed quadrilaterals theorem. So if we have any quadrilateral that is inscribed in a circle, then its opposite angles are supplementary. So we see this quadrilateral A, B, C, D, inscribed quadrilateral. That means the quadrilateral is inside the circle. It's inscribed. It's inside the circle. So we have a quadrilateral in here. That means its opposite angles are going to be supplementary. So, for example, if angle A was 70 degrees, then the opposite angle, the angle that's across from it, would be angle C. And supplementary means they have to add up to 180 degrees, right? So that would make angle C 110 degrees. All right? And then let's say angle B is 100 degrees. Then angle D would be 80 degrees, right? The opposite angles are supplementary. The opposite angles add up to 180 degrees. All right, so let's work some problems applying that. So, number 1, find the value of x and y. Well, let's start with x. So, x is opposite of 108 degrees. So, all we have to say is 180 degrees minus 108 degrees. That's going to give us 72 degrees. Now, this says x degrees, so the value of x is just going to be 72. Because if I say that x is 72 degrees, then if I substitute that in here, I get 72 degrees, right? So I'm just going to say x is 72. All right, then we do the same thing to find y. So I'm going to say 180 degrees minus 88 degrees. That's going to give me 92 degrees. So y equals just 92. All right. There we go. We found x and y. Just knowing that if it's a quadrilateral, the opposite angles are supplementary. Now, let's do number 2. Find the measure of angle PQR. Well, here's the angle we're trying to find. This angle PQR, that's what we're trying to figure out. So y squared plus 48 degrees. Now, we don't know what's opposite of it. All right, so we're not going to be able to add anything to it and get 180 at this point. What we need to do is look at the other information we're given. This angle P and this angle R, they're opposite of each other. So that means that those angles must be supplementary. So if I say 6y plus 1 degrees, and I add 10y plus 19 degrees, that should equal 180 degrees, right? If I add up those two angles, they should equal 180 degrees. So just to make this a little simpler, I'm going to go ahead and get rid of the degree signs because they all have it. I can divide it out from every term. So I'm going to say 6y plus 1 plus 10y plus 19 equals 180. 6y plus 10y is 16y. Combine like terms here, right? 16y. And then 1 plus 19, we're saying 20. So 16y plus 20 equals 180. Subtract 20 on both sides. We're going to get, I'm going to move right here, 16y equals 160. Divide by 16. We're going to get y equals 10. So the value of y is 10. So I know what y is now. So in order to find the measure of angle PQR, which is what we're trying to find here, that's what we're trying to figure out, y squared plus 48. All I've got to do is substitute 10 for y, so I'm saying 10 squared plus 48 now. So 10 squared is 100 plus 48. So that's going to give me 148. So the measure of angle PQR is 148 degrees. That's the measure of angle PQR. So I hope that video was helpful for you. If you have any questions or confusion, I encourage you to rewatch parts of the video. But make sure you come to class with questions and ready to work. Good work today. Thank you, Collegiate Scholars.